In this video, I would like to talk about determinants, actually section 8.4, and it will be useful to us to find out about another method to solve systems of equations, which is called Cramer's rule, and determinants will play a role in finding inverse matrices in section 8.3. So when we talk about determinants, we talk about determinants for square matrices, either 2 by 2 or 3 by 3. So for 2 by 2, the process is fairly simple. We have right here, if you notice, something that's called a diagonal, which goes in this direction from top left to bottom right. So we typically have the elements in the diagonal, A times D minus the product of the elements of the diagonal, which is B times C. So that's how we get the determinant. So like for example, in this matrix we have 4 times negative 5, which gives us negative 20, minus the product of negative 2 times 3. So minus a negative gives us positive, which in turn gives us negative 14 as a determinant. For 3 by 3, the process is quite a bit more involved. What we usually do, now there are certain elements called minors and cofactors, but I will spare you the terminology and I'll just walk you through the process. We're going to get down to 2 by 2 matrices. Typically, most textbooks, we consider the first column, and that's what we got. I actually learned to compute the determinants using the first row, which should give you the same answer. But let's talk about the first column. So we're going to go down all the 3 elements of the column. So first we start with A, and we likely notice we cross out the row and the column it's in, and so what we have left is a 2 by 2 matrix right here, and we're going to need the product of A times the determinant of the given 2 by 2 matrix here. That's the first part. Now we have the other 2 parts similarly. For the second part, we have second entry D, same process. We lightly cross out the row and the column it's in. Notice how we have B, C, H, K left over, and that would give us the new determinant. So it would be D times the determinant of 2 by 2 matrix. Then we have the third part, which, as you may guess, here we have G, and we kind of repeat the process to get this 2 by 2 matrix right here. So we have the third part. Now here's the important part. When we put these parts together, we alternate the sign. We keep the same sign, whatever the sign of A was originally, positive or negative. We change the sign of the second part. Here we'll write it as a minus, but it could be a plus. Change the sign, and we keep the same sign for the third part. So keep for the first one, change the sign for the second, and keep the sign for the third part. And we add the parts together. And that's how we get the determinant, which we can check with a calculator, so that's useful. But here, let's try it here. So let's say if we take 1, notice how we lightly cross off the row and the column it's in. And here we have the leftover matrix. That's how come we get the first part. Then, let's erase it for the second part. We're going to do the same thing for the second element. With a 2, again, we lightly cross out the row and the column it's in. Notice how we have the leftover matrix, and here's our second part. Notice the minus sign here. And then let's try the third part the same way. And let's try it. There you go. And notice we have the leftover matrix right here. And typically if we have zeros in a row, or all of them are zeros, we have the 0 for all 3 parts, and so the determinant is 0. And then we do the same thing with the other determinants. So where we're going to use it next would be in Cramer's rule, which is the rule which is going to be in the next video for both 2 by 2 and 3 by 3. So look for the video on Cramer's rule next.